Hello, this is Mrs. Meyers, and we are going to be learning about points, lines, and planes, the basics of geometry. And this is our lesson 1.1. So to start with, we are going to add a point to the right of this point A, and we're going to call it point B. Notice points are labeled with capital letters. The definition of a point is an exact location in space. We can't actually draw an accurate point because an actual definition of a point really means that it has no dimensions. It's an exact pinpoint location in space. When we draw a point, we actually draw a dot that has dimensions, but a point is really more of a concept. Use your ruler now to draw a straight line through point A and B. So I'm not going to use a ruler, but it's going to look like this. And the definition of a line is an endless, straight collection of points. It goes on forever in both directions, which is why we put arrows on both ends of our line. If we draw another point to the right of point B, we're going to label that C. And if we name our line, we're going to use any two letters to name the line. This could be called line AB, or line BA, or line CA, or line BC, any combination of the two letters. Never use 3, never use 4, never use 1, always use 2 letters. 2 points to name the line. It doesn't matter what order, AB, BA, same line. Notice the notation above the AB is a bar with arrows on both sides. That symbol means line. So when you see this written, you're going to say line AB. Sometimes they will mark a line a different way. They'll use like a lowercase script letter. And if that notation is used, we have to write out the word line, and that would be line M. That's a little less common. Usually we're naming it with 2 letters. Okay, points A, B, and C are said to be collinear. This means that they are able to be contained by the same line. So notice it says able to be contained by the same line. So if I put a point over here and called it, Z, well, A, B, and Z are not collinear because you can't get one line that goes through A and B and Z. That would not be a straight line. But if I asked, are A and Z collinear, you might be tempted to say no because Z is off the line. But actually, A and Z are considered collinear because we could draw a line through them, right? We could connect them by 2 points. We could connect those 2 points with one line. Trying to move my... Oh, no. Okay, well, gotta erase that. Sorry about that. There we go. All right, let's get rid of point Z. That's not part of our diagram. Okay, so able to be contained by the same line means collinear. These 2 lines are said to intersect at point B. If we draw a second line now through point B, use your ruler again, and a second line through point B, these 2 lines are considered to be intersecting. They intersect at point B. Definition of intersection is all the common points. When you're talking about 2 things that come together, you're talking about the points that they have in common. So the intersection of this in this diagram would be point B. That's where they intersect. All right, a postulate is a statement that we accept as true without proof. So sometimes in this class we're going to formally prove things, but sometimes we're just going to accept something as being true without proof because it's not able to be proven formally. So this is our first postulate right here. It says if two lines intersect, then their intersection is always 1 point. So that we're just going to accept that as being true. When we intersect two lines, they're always going to intersect at 1 point. Now, lines don't always have to intersect, but when they do, it's going to be at a point. All right, then our next direction says draw 2 more points on the line, D above B and E below. So we're going to put a D here and an E here. And then we're going to turn the page, and I've recreated an image here so that we can refer to this without having to flip our page back and forth. And we're going to continue to refer to it and name some new vocabulary words here. A ray is a part of a line with one endpoint that extends forever in one direction. So a ray could be starting at, let's say, point B and goes through E and continues forever in that direction. I just highlighted ray BE. So the notation for a ray is this arrow that's always pointing to the right. The first letter is always the end point, where it begins, where the point, where there's an actual point, not an arrow. That's what you have to name first. So start at B, and then this basically says go through E and continue forever. That's ray BE. Let's take another example, like ray AC. Ray AC starts at A, then goes through C, and continues forever. But there's another way to name that ray. You could call it ray AB. That is the same ray, because it starts at A, that's the end point, boom, boom, that's the end point, right? Starts at A and goes through B and continues forever. Well, if it goes through B and continues forever, it also goes through C, right? So we can name that ray, this red ray here, I can name it either AC or AB. So sometimes there's more than one way to name the same ray. Okay, an angle is is the space that we measure in degrees between two intersecting lines or parts of lines, right? So it could be rays or whatever. And they have a common vertex. Vertex is the point of intersection in an angle. So from our diagram, we have a few angles that we could name. The symbol for angle looks like this. Looks like an angle. Okay, so we can name angle ABD, let's say. Angle ABD would be this angle right here. Start at A, go to B, end at D. That would be that angle there. Let me erase my rays so we can look more carefully at this diagram. That's one example. Another angle that we could name, let's say start at D, go to B, and end at C. DBC would be another angle. There's many more. Okay, so if you use your protractor to measure your angles, and notice that the symbol little MA with an angle. This means the measure of angle ABD. So when we actually want to come up with a degree measure for the angle, that's the notation that we use, measure of angle ABD. When it says that, we're going to put an actual number there. So you can use your protractor and measure. If I measured mine, ABD comes out to 95 degrees. And ABE comes out to 85 degrees. And DBC is also 85, and CBE is 95. Now, yours might be different, of course, if you're using your diagram that you did on page 1 here. This little diagram up here is a little too small to use, but anyway, you might get different numbers here. But notice, whether you got different numbers or not, there's a couple of pairs of angles that we say are congruent. If you remember, congruent means exactly the same size and shape. So angles that are congruent for me would be angle ABD and angle CBE. No matter what your angle measures are, that should be true for you as well. ABD is congruent, same measure as CBE. And then the other pair would be angle DBC and angle ABE. You might have seen a congruent symbol before. It looks like that. We'll learn that more detailed in the future. All right, supplementary. Remember, supplementary means adds up to 180 degrees. So we have a few supplementary angles here, lots of pairs actually. If you notice in the diagram, when they're supplementary, it means that they are basically forming a straight line. Right? This angle plus this angle equal 180 because the whole straight angle was 180 degrees. So we have some supplementary angles here. For example, angle ABD is supplementary to angle ABE. Another pair would be angle CBE is supplementary to angle ABD. And there's two more pairs. Which angles are acute? Remember, that means less than 90 degrees. And obtuse is greater than 90 degrees. So acute would be anything on your diagram that would be less than 90. So for me, it would be ABE and DBC. And obtuse are the other two, greater than 90. It's important to kind of realize that when we intersect two lines, there's always going to be two acute and two obtuse angles, unless you've intersected them at exactly 90 degrees. All right, adjacent angles. Another important word, adjacent angles. Angles that are right next to each other. They share a ray. They have a ray in common and a vertex. So they have the same vertex. So adjacent angles are angles that are right stuck together. ABD is adjacent. ABD is adjacent to two angles actually. It's stuck together with this one, which would be called DBC. It's also stuck together on this side with this one, which would be called ABE. So DBC and ABE. And DBC is adjacent to ABD, so DBC, this one, is adjacent to ABD, and on the other side would be CBE. Okay, so this is really the important piece of this lesson right here. The angle addition postulate is going to be one of the things that we really use a lot. And it basically says that the measure of one angle plus the measure of an adjacent angle equals the measure of the big angle formed. So what this means is, in our diagram, right, this angle plus this angle adjacent to it, we said adds up to the whole big angle formed. It happens to be a straight angle in our diagram, which is 180 degrees. It doesn't always have to be 180 degrees, though. Two adjacent angles can add up to something besides 180 degrees. If we fill in these equations using our diagram, though, measure of angle ABE plus the measure of angle EBC. So ABE, let's look up here again, ABE, ABE plus EBC equals what big angle? If you stick those two together, it makes this big angle. So we would call that ABC. And DBC plus what equals DBE? DBC plus what? DBC plus what equals DBE? DBC plus what equals DBE? So we're looking for this big angle DBE. So the one that's missing there is this one, which is EBC. All right, it might be easier to understand the concept of angle addition postulate if we do this one problem here. Notice right here, I really want to stress how important this is, labeling the diagram. When they give you information, write it on your diagram. So measure of angle RYW. RYW is 43 degrees. I'm going to label that. RYZ. RYZ is the whole thing. I want you to label it this way. Don't go around this way. We don't want that. Inside, between these two rays, is 118 degrees. And then they tell you to use X to represent the measure of angle WYZ. So we're going to put an X right here. The equation they're looking for here has to do with the angle addition postulate, right? Because the measure of angle RYW, this one, plus the measure of angle WYZ, that's the angle that's adjacent to it, equals the whole big angle RYZ, this whole big angle RYZ. So if we substitute in what our given information, RYW is 43 degrees, plus WYZ is X, equals RYZ is 118. Now we can solve this algebraic equation, and we just subtract 43 from both sides. And we get 75. Okay, so at this point you should be able to do the worksheet that is labeled 1.1 P1, I believe it's labeled, and we can go over that in class. Thank you.